Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to another episode of the Reliability Matters podcast. We are broadcasting from our friend and colleague's booth, Trevor Galbraith's booth at Global SMT, and we are broadcasting live from his booth and his comfy chairs with the always trusty, always capable Summer and David running things behind the lights and behind the camera. So thank you two for your production work. My guest right now is Marco.Sanchez. He's with SMT North America, and we're going to talk about reflow and specifically controlling a reflow oven. But before we do that, Marco, welcome to the show. Tell me a little bit about SMT. What doesn't SMT produce? But what types of products is your company known for? And then we'll get into a little bit more specific.
Our company is a German brand. We produce some reflow systems, and also we have some reflow system with a vacuum chamber. Additional to this, we have some thermal systems, as a cube and other system for curing process, for conformal coating, epoxies, and other kind of products.
Very good. And you're exhibiting here at the show, I would assume, right?
Yeah.
Lots of equipment?
Well, actually, we don't have equipment, but we have the presence, and we are still ready to share information about those.
Excellent.
systems.
There's several booths here that did not bring equipment. I think the jury was still out about how many people would come to the show and how much equipment to bring, and that fine balance, because it's not cheap to bring equipment to a show. But the show's been good.
Yeah, super. Yeah, we
Excellent.
have some customers, and that is
Excellent. I guess to really answer that, I'd have to ask you that question in 6 months, right? Because it takes a little time.
Exactly.
Let's talk about profiling. Traditionally, one would have an oven, and one might buy a thermal profiler made by a number of companies, which will basically either measure the board or measure points in the oven. It'll tell them what temperature the oven is at, or the board is at, in a particular part of the board or a particular part of the oven. And that information is kind of statistical information, right? Your company in your ovens do something a little bit more comprehensive than that. Why don't you explain to me and my audience what SMT's contribution to that control and monitoring thermal-wise brings?
Well, this is a really good good approach that we have. We have a solution for customers. We call it monitoring. The monitoring system is quite interesting because usually we consider two parameters for a profiling process. One of these is the heatings setting,
So
and
the actual temperature.
exactly. And the second one is the conveyor speed.
Mm-hmm.
But also, it's important for us to consider the fan speed as well. And we are working on these three parameters from the beginning. So we do this, and then we're still checking all the time these three parameters in order to keep the high quality of the products.
So you're checking temperature, you're checking conveyor speed, and you're checking fan speed.
Exactly.
And temperature, I understand. That's obvious. Conveyor speed, I understand, because it doesn't matter what the temperature is. If you're flying through at 1,000 feet a minute, the board's not even going to get warm. But fan speed, obviously, is the rate in which air is being evacuated from the tunnel. Is that correct? And if you have too slow a fan speed, you're going to generate more heat. If you have too high a fan speed, you're going to generate less heat. Is that a fair assumption?
Yeah, but also it's important to say that our system, we can monitoring. I mean, we can control it through, in the case of fan speed, with a frequency converter. In the case of the motors, we can measure the currency of the motors of the transport speed. In the case of the heaters, we can controlling and still monitoring through via software. So we can observe these parameters in order to guarantee the the control of the process, the profiling process. And then if something is wrong, the system will send alarm to the maintenance team or the production team in order to identify that something is wrong. And with that, we can keep the high quality of the product.
So what happens when, hypothetically, your conveyor speed is perfect, your temperature is perfect, but your motors are drawing more current than you expected, which would, I guess, one would insinuate from that you're going too fast. Your conveyor speed's too fast. Or if something's wrong with the motors. What happens in that situation?
Our system is still monitoring the currency and still bringing this adjustment to the motors in order to keep the constant, let's say, currency that they need.
So
if
it notices it's drawing too much current, will it then try and reduce the current to the motor? So it's not just an alarm. It actually is control.
Yeah.
Okay.
Exactly.
So there's a feedback loop.
Yeah, exactly. It's still controlling
and
monitoring.
So if does it compare if the operator, say you were running a foot a minute, just for the sake of numbers, running 1 foot per minute, and the operator turns it up to 8 feet per minute, will it then allow it to run 8 feet per minute, or does it somehow know that the operator is trying to get out early so he can go on a date on a Friday night, or will it compare what it's just been told to do with what the actual readings are and think that if that's what he wants, that's what he's going to get?
But at the end of the day, if you perform some change in the system will respect the change that you
respect the change. Yeah, that makes sense.
Somebody just come and adjust the setting, the system will adjust the system.
And it'll say, okay, if that's what you want, I'll make sure you're going to get that.
Exactly. At the end of the day, most of this kind of, let's say, setting is controlled by the engineering department. So they can keep a control of that, And also we can bring this solution a different level of access of the people.
Right. So an operator can theoretically scan a barcode. It knows what profile to pull up.
Yeah.
And that automatically loads. The operator can't.
Yeah. There is also a solution that we already have. Yeah.
Excellent. Sometimes keeping operators away from buttons is a good idea, right?
Yeah.
If they're like me, when I was a kid, I would push every button. My dad would always yell at me, "Look with your eyes, not with your hands," because I would always push buttons if there was a button to push. So,
and most of the time, the people still trying to do some change, but this is part of our challenge to bring the control and the constant monitoring to the people that is still in charge. In this case, the engineering department, production leaders, and so on, just to keep the control, the things, and then with this kind of solution, bring the control to the people and also the high quality to the final customer.
If there's a situation in your monitoring system that it can't fix, say pulling too much current on the motors, and you send a signal to lower it, it's just not lowering it. Does that create an alarm condition? Does that notify somebody?
Yeah.
And who does it notify?
They appear the signal in the monitor. Our system is also a connection for the industry 4.0. So also we can bring this kind of connection to the team.
Do you do that through CFX or some other standard? Do you know the 4.0?
No. I know that we have some kind of this connection, but it depends on the company.
Right. So that goes into a larger information system and keeps the stats and things like that.
Internal information, for the internet and so on, for the companies.
A few months ago, we published a paper. I'm in the cleaning business myself, and so we always look at contamination. How much contamination is on a board? Because too much contamination is bad for a board. And we were able to correlate peak reflow temperature to contamination. So we took a series of SIR test boards and ran them at proper, quote unquote, proper reflow temperatures, and then ran contamination studies on them and determined that at proper reflow temperatures, the amount of contamination was acceptable. Then we ran that profile at 5% lower. 5%. Okay. Not a huge amount.
Okay.
From a solderability standpoint, from an intrametallic bond standpoint, perfect shots. Things weren't going to fall off. Visually, they look good. But from a contamination standpoint, we went from very high levels of cleanliness to very low levels of cleanliness, high levels of contamination, by just allowing the peak reflow temperature to drift 5%.
Okay.
So that, in addition to the quality of the solder joint and other things, that's just one more reason to ensure that your profile and that your oven is producing boards thermally accurate.
Yeah, exactly.
Because people will set up a qualified manufacturing process based on perfect parameters. And then the moment they set up the perfect parameters and say, okay, this is it, lock it in, this is what we're going to run, within 5 minutes, something changes, right? There's all these external variables and internal variables. That really taught me a lesson on how important it is not just to set up the right profile, but to maintain the right profile.
Exactly.
And to be warned, ideally, to never have the profile change. But if it does change, to have the oven have the ability to fix it. And if it doesn't have the ability to fix it, to let somebody know, right? That seems to be, one of the key steps to reliability.
Yeah, exactly. And this is really interesting because most of the
Hold
time,
this up a little bit.
Yeah, as you know, these variables keep changing now because there exist another variables, mechanical stuff and so on. So this is quite important for us that bring this solution that the customers can monitoring these critical points in order to keep this quality and this setting, and then bring to the product the quality that the customer is still looking for. So this is really, really important for us also to bring this solution to the people or customer for sure, and then they can have this product with a high quality. And then most of the time that the system is still working well, that the system is still producing, that is important thing, and then continues with the work. And then they can observe that his quality is really good and his system is still available for continuous working.
Right. Well, that makes a lot of sense. Marco Sanchez from SMT North America, thanks so much for sharing that technology with me and my audience. And it's fascinating. And keep up that good work.
Yeah. Thank you very much. It's a pleasure to be with you.
Take care.
You too.
Bye-bye. My guest right now is Colin Harper. He's with BPM. And, first of all, welcome, Colin.
Thank you, Mike. I'm very happy to be here.
Thanks for sitting in the hot seat.
Sure, not so hot yet.
Not so hot yet, but certainly comfortable.
It is.
Better than standing on a trade show floor, right?
Absolutely.
In a booth. First of all, how's the show?
It's been a good show. The traffic, I think everybody would admit, is down from years past, but it's great to be here and love to reconnect with customers and associates. So really, really happy to be here.
Yeah, it's nice to, as I've said many times, it's nice to see people, not pixels, right?
Absolutely.
People in 3 dimensions. It's great to have conversations in real time rather than looking through a teleprompter. Your company makes programming equipment.
We do. It's 37 years.
I'll say it's for my audience's benefit, but it's really for my benefit. Tell me what that means. Put that into kindergarten terms for me. Obviously, devices need to be programmed. What types of devices and what specifically types of things are you loading into these devices?
Well, we're putting digital data into microcontrollers, EEPROMs, FPGAs, UFS devices, kind of the whole gambit of semiconductors that need to have pre-programmed content. We support that on our platforms.
So many years ago, when our company was very young, we had a EEPROM,
right?
Electrically erasable, with a glass window on it, and you put it under a UV light.
Right.
You erase all the history. And
you got it.
And we had that little programmer, which was just a socket with a little lever to tighten down the pins, and we'd load some software into it and pull it out and do it again, and cover the window so it wouldn't erase itself. But obviously, yours are more automated. Ours was one dip at a time. Yours is obviously much more automated than that, right?
We do. We still sell a lot of manual programmers to engineering firms and first article development and that type of thing. And then on the high end, we have fully automated systems that support the same devices. Frankly, our technology is universal, so the way our product works, if you program the device on a manual programmer, you're going to get the same results on the automated platform as well. Yeah,
excellent. So I read a press release recently that your company is on its 10th generation program.
Yeah, we were pleased to announce the BPM 310 at Productronica just this last November, and showing the machine here as well.
So whenever I see new and improved or next gen, my mind goes to what's better from the 10 to the 9, and what did the 9 improve over the 8? And so, what is in your world of programming equipment, what constitutes a generational change? What do the machines do today that maybe they didn't do a couple of years ago and they didn't do 30 years ago? What constitutes evolution in your industry?
Well, in our case, it represents, of course, universal evolution. Our 10th generation supports UFS programming as well, whereas the 9th generation did not. UFS was a disruptive technology a few years ago, and so 10th generation not only supports UFS, it also brings the legacy technology and all those other things with it. And then the other big thing is the industry wants value, as you know from all the folks here. And so we are doubling the socket density per programming site. So we have a small footprint machine, our BPM 310, that can program up to 48 devices concurrently, whereas that used to be reserved to our larger flagship platform and we have so much confidence in the BPM 310 that we decided to discontinue the 4000 series machine. So it really speaks volume to the capability of that platform, and certainly the market has responded favorably because the value proposition is pretty obvious.
Right. And how automated is your technology? Do the devices, are they hand loaded, 48 devices, and then your machine does the programming? Is it auto loaded and auto ejected, so to speak? Or?
Yeah, good question. So programmable devices like other semiconductors can be bought in tape. They can be bought in JEDEC tray and tubes. So we handle all 3 types of media and any combination thereof. So if you want to buy JEDEC trays or parts in JEDEC trays and then output to tape and reel, then our machine can do that. And of course, these are optional things.
Sure.
Some customers say a small OEM, maybe they'll only buy parts in JEDEC tray. And so they don't need the taping module. So our machines are very configurable, and you can add these features in the future.
So your company is actually providing the add-on technology to put these things on tape and from
Absolutely.
one format to another format in terms of storage.
Exactly.
So you can take them from JEDEC trays and put them on tape and reel. All part of the programming machine. I mean, optional, clearly, but all part of the programming machine.
And it's baked in. You simply buy that feature in the future if that's when you need it. The same thing for the socket capacity. I mentioned the BPM 310 can have up to 48 sockets. Perhaps you're only programming 200,000 to 500,000 devices per year, and you only want to start with 2 programming modules or 16 sockets. Happy to help you there, and then as your needs grow, then you can add the additional capacity as your volume increases.
How has the technology been evolving in terms of speed of programming for a given data size or a given amount of volume of data to go on a chip? I remember when I was programming those EEPROMs, it would take about a minute, maybe 2 minutes to download a program, which was a very small program by today's standards. Has that speed increased? Is that something that one model would be faster than another model, or is that just kind of an industry standard?
Yeah, great question. Exponential speed improvements, no doubt. I can't give you any data off the top of my head from our 6th and 7th generation, but for example, UFS devices, really high speed, high density devices, we can read at about 440 megabytes per second and write at just over 200 megabytes per second. So a lot of data going fast.
Yeah.
Right.
If I had that speed back in my EEPROM days, I would put it in and take it out instantly. I wouldn't even see the program speed, considering the size of the chip. How has IoT, automotive, landed on your industry? Are they automotive, for example? Are they large consumers of programmable devices, or do they buy a different type of technology where in the wafer process the coding is all put in? I don't know if that's what happens, but
yeah, definitely.
Not every device is programmed, right?
Sure.
After the device is made, some have functions as they're made. Is that a correct statement? Or is everything ultimately programmed through a device programmer?
Well, I guess there are a number of methods for device programming. We specialize in offline programming in socket, but certainly a large part of the market also programs on board. So we compete
Right.
with that. The reason offline programming is really good in many instances is because of the potential bottleneck that you have on your SMT line. And, you can imagine if you're trying to program back to the UFS device where you have
Right.
huge densities you're trying to program on that board, your beat rate is really important. And so to try to keep up with the beat rate and program just in time on board, the amount of resources and equipment necessary to
Sure.
do that would be astronomical. So we're taking a very important but relatively it's a very important process, but we're doing it upstream, so there's no bottleneck.
Right. You could take as long as you want, as long as you start early enough in the process.
Exactly.
You're not going to slow down the conveyor line.
And one automated machine can support multiple manufacturing lines, whereas you can imagine if you're programming in line or in SMT, you've got to have dedicated resources for each production line.
Yeah,
Correct.
exactly. So has auto and IoT positively, negatively influenced your market?
Oh, yeah, absolutely. Both automotive and IoT. Encryption is also a really important feature for IoT devices. You want to make sure that the devices are secure and that as they're updated in the field in application, that somebody is not doing something nefarious, so to speak.
Right.
So we have BPM Encrypt is a feature that we have in our software that allows custom security solutions to be developed as needed.
One final question before we wrap up. I always like to ask manufacturers of equipment this question. If you were looking for something that your company produced and you didn't work there, what perfect questions would you love your customers to ask you? What questions would you ask a supplier of programming equipment that will allow the supplier to respond accurately with something that will work for them? Sometimes customers don't give you all the facts.
Right.
And, we've all been there. We provide equipment based on the limited facts we have. And it turns out those facts weren't accurate. Sure. And maybe the machine is not the best for their need because we didn't know what their need was. What types of questions should your customers be asking you and any other programming equipment company?
I think it's mostly about the future when it comes to device programming. There's many thousands of new devices coming onto the market each year that are to be programmed. And so I think the most important question is, can you reasonably assure us that your technology will be as beneficial 2 years from now as it is today? And I can tell you this, and this is based on fact, 6th generation, obviously we're at 10th today, but we have thousands of 6th generation programming sites still in operation. So that's a testament to the test of time. Now, it cannot support, for example, UFS devices. There are these disruptive technologies that do take place. But I think it's more the future proof. Can you be relatively certain that what I'm buying today will take me for 5-10 years into the future?
Right. I've often said, in fact, we talked about it yesterday on the show, it's not only a question of how well the equipment's built. It's a question and how reliable it is. It's a question of how relevant it is.
That's a great
point.
Can I use that?
Please.
Yeah,
yes,
okay.
Absolutely.
Okay.
Because, we build cleaning equipment, and the machines we sold 30 years ago some of them are still running, but I don't know what they're cleaning with them because things didn't look like the boards today 30 years ago, right?
Sure.
And I would assume the same in programming and pretty much every part of our industry is things change at lightning speed. And, you try and engineer enough relevance in there, but sometimes we don't know what we don't know. Disruptive forces, like you said.
Right.
Are your machines upgradable? Are there software features that you update over years, or is the capability locked in at the time they purchase it?
That's a great question. So, we're a hardware company, but frankly, if you look behind the scenes at BPM, we have more software engineers and folks writing code than hardware because, again, you build a programming site technology that's built to last, and it's test of time. You do that every, let's say, 3 to 5 years. And then you have to continually update that toolbox. And so that's what we do weekly. We have software updates and on a weekly basis supporting the customers we have around the world.
Yeah. Excellent. Well, Colin Harper, BPM, thank you so much for being my guest today. I appreciate your knowledge. I appreciate you teaching me a little bit about programming, something I wasn't counting on learning today. So,
Mike,
thank
you. Yeah, it was a pleasure.
All right. Enjoy the rest of the show. And thank you, my audience, for being part of the Reliability Matters podcast family. I appreciate you being here. And also my thanks to Trevor Galbraith at Global SMT and Summer Dean and David Burford behind the scenes, pushing buttons and making us seem like we know what we're doing. So thank you very much. And once again, if you would like to be notified of future episodes of the Reliability Matters podcast, be sure and subscribe on your favorite podcast app. We're on Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, and virtually wherever you get your podcasts. And if you're listening to this in your car, on the treadmill, or wherever you're listening to it, and you would like to see what it actually looks like, what my guest looks like, and God forbid me, we also have a YouTube channel. Just search Reliability Matters or Concept to Creation, my other podcasts, on YouTube, and you can watch and hear it simultaneously. So once again, thank you very much. And from San Diego, from beautiful sunny Southern California in San Diego at the IPC APEX Expo, thanks for joining me. I'll see you again in a couple of weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.